Here we have a SAT math question. Let's go the information. If f of x positive 1 equals to 1/4 times f of x, which of the following equations could define the function f? Okay, so we have the information that is f of x positive 1 equals to 1/4 times f of x. Okay, to get the denominator 4 over here, I multiply both sides of this equation by 4. Then I'm getting 4 times f of x positive 1 equals to 4 times 1/4 times f of x. So here this 4 will cancel out. So I'm getting f of x equals to 4 times f of x positive 1. So I just write this stuff over here on the left side. I'm writing this stuff on the right side. So that is the function f of x and 4 times f of x positive 1. Both of them are equal. Okay, so now let's consider the stuff we have on the right side. So here 1 is added to x. So what does it say? So this is an horizontal translation of 1 unit to the left. And here 4 is multiplied by f. So this one says there is a vertical stretch by a factor of 4. For example, let's consider a point a comma b on the graph of the function f of x. Now we can apply two transformations on this point a comma b. That is horizontal translation of 1 unit to the left and vertical stretch by a factor of 4. So when I do horizontal translation of 1 unit to the left, I have to subtract 1 from the exponent at this point a comma b. So when I subtract 1 from the exponent a, I'm getting a negative 1. And also to do the transformation, there is a vertical stretch by a factor of 4. I have to multiply the y coordinate b by 4. So then I'm getting 4b. Okay, now if I have the point a comma b and the graph of f of x, then I must have this point a negative 1 comma 4b on the graph of f of x, because f of x and 4 times f of x positive 1 are equal. So when I have this point a comma b on the graph of f of x, then I must have this point also on the graph of f of x. Okay, now let's apply this logic in each and every option. So now let's check the option A. So in option A, for my convenience, I'm going to get a point on the graph of the function f of x over here. So to make the process easier, I'm going to plug in x equals to 0 into this function. So when I plug in x equals to 0, what will happen? Let's find the value of f of 0. So that is 1/4 times 1 over 8 to the 0th power. So then 1/4. So anything to the power 0 equals to 1. So the evaluation of this one is just 1. So 1/4 times 1 is just 1/4. So when I plug in x equals to 0, the y coordinate is 1/4. So this is a point we have on the graph of f of x in option A. Okay, now apply the two transformations of what I have explained over here. That is the horizontal translation of 1 unit to the left and vertical stretch by a factor of 4. Okay, so now if I apply the horizontal translation of 1 unit to the left, so I have to subtract 1 from the x coordinate, then I'm getting 0 negative 1 is negative 1. Now to get the point y coordinate after vertical stretch by a factor of 4, so I have to multiply the y coordinate by 4. When I multiply this 1/4 by 4, I'm just getting 1. So when I have this point 0 comma 1/4 on the graph of f of x, and I must have this point also on the graph of f of x. Already we know that we have this point on the graph of f of x because we got this point by plugging in x equal to 0 into this function, and we got 1/4 as y coordinate. So I know that I have this point on the graph of f of x. Okay, now I have to verify whether I have this point negative 1 comma 1 on the graph of f of x. For that, I have to plug in x equals to negative 1 into the function, and the y coordinate must be equal to 1. Let me check it. So f of negative 1 equals to 1/4 times 1 over 8. Okay, now I have to plug in x equals to negative 1. So 1/4. So when I take negative 1 for 1 over 8, it will become just 8. So 4 goes into 4. 1 times 4 goes into 8 twice. I'm getting 2. So that is when I plug in x equals to negative 1, I'm getting y equals to 2. I don't get this point. So when I plug in x equal to negative 1 into this function, so option A does not define the function f. Okay, now let's check option B. To check option B, I need a point on the graph of the function f of x. We have an option B. So as I said earlier, that to make the process easier, so to get a point on the graph of f of x over here in option B, let me plug in x equals to 0. When I plug in x equals to 0, let's find the y coordinate. So for that, we have to plug in x equals to 0 into the function over here. Then I'm getting 8 times 1/4 to the 0th power. Then I'm getting 8 times. So anything to the power 0 equals to 1. So 8 times 1, I'm getting 8. So I'm getting the point 0 comma 8. So when I plug in x equals 0, I'm getting the y coordinate 8. So on the graph of the function f of x in option B. So we know that 0 comma 8, we have this point on the function f of x. Okay, now let's apply the two transformations I explained over here on this point 0 comma 8. that is the horizontal translation of 1 unit to the left. For that, we have to subtract 1 from the exponent 0. When I subtract 1 from the exponent 0, I'm getting negative 1. That is 0, negative 1 is just negative 1. Okay, to get the y coordinate, I have to apply the vertical stretch by a factor of 4. For that, I have to multiply the y coordinate by 4. 4 times 8 is 32. Okay, already we know that we have this point 0, 8 on the graph of f of x in option B. Then we must have this point negative 1, 32 also on the graph of f of x in option B. So for that, what we need to do is we have to plug in x equals to negative 1 into the function f of x, and we must be getting the y coordinate 32. Let me verify. So f of negative 1 equals to 8 times 1/4 to the power of negative 1. So equals to 8 times, when I take the exponent negative 1 for this 1/4, it will just become 4. So 8 times 4 is 32. When I plug in x equals to negative 1, I'm getting y coordinate 32. Yeah, we have this point negative 1, 32 on the graph of f of x we have in option B. So the correct answer choice for this question must be option B. Anyways, we can verify the remaining two options C and D also. So the same thing, whatever stuff we have done for option A and option B, the same thing we have to do for option C and D. Okay, now let's verify option C. To verify option C, first let's plug in x equals to 0 into the function f of x. We have an option C to get a point. So then f of 0 equals to 8 times 4 to the 0th power. So 8 times 4 to the 0th power equals to 1. 8 times 1 is 8. So now we have the point 0, 8 on the graph of the function f of x in option C. So now let's apply the two transformations I have explained over here on this point 0, 8. So horizontal translation of 1 unit to the left, that is we have to subtract 1 from 0, then I'm getting negative 1. So vertical stretch by a factor of 4, that is we have to multiply this y coordinate 8 by 4, then I'm getting 32. Okay, now, so already we know that 0, 8 is the point we have on the graph of f of x in option C. Then we must have this point also on the graph of f of x. So to verify that, I have to plug in x equals to negative 1 into the function f of x, and y coordinate I must be getting 32. Let me verify. That is f of negative 1 equals to 8 times 4 to the power of negative 1. So 8 times is 4 to the negative first power can be written as 1/4. So 4 goes into 4 1 times, 4 goes into 8. Twice, I'm getting 2. That is when I plug in x equals to negative 1, I'm getting 2. So I don't get this point negative 1, 32 on the graph of f of x in option C. So the stuff we have in option C does not define the function f. So now let's verify option D. To verify option D, the same thing. That is, we have to get a point on the graph of f of x in option D. For that, we can plug in x equals to 0. So let's plug in x equals to 0 into the given function f of x, in option D. So f of 0 equal to 1/4 times 8 to the 0th power. So 1/4 times the value of 8 to the 0th power is just 1. 1/4 times 1 is just 1/4. So we have a point 0, 1/4 on the graph of f of x in option D. Okay, now apply the two transformations over here on this point. So that is horizontal translation of 1 unit to the left. That is 0, negative 1 will become negative 1. So vertical stretch by a factor of 4. For that, we have to multiply the y coordinate 1/4 by 4. When I multiply 1/4 by 4, I'm just getting 1. So we know that the point 0, 1/4, we have this point on the graph of f of x in option D. Then we must have this point also on the graph of f of x. To verify that, we have to plug in x equals to negative 1 into the function over here in option D. So then f of negative 1 is equal to 1/4 times 8 to the power of negative 1. So 1/4, so this 8 to the negative first power can be written as 1/8. So I'm getting 1/32. So that is when I plug in x equals to negative 1, I'm getting the y coordinate 1/32. So this point is not on the graph of f of x in option D. So the correct answer choice for this question is option B.